All right, in chapter 5, section 2, we are now going to change our look at polygons from being triangles to quadrilaterals. And quadrilaterals means four-sided figures. And there are three different conditions that have to be met for there to be a quadrilateral. First of all, the sides have to close. The angles have to add up to 360. And they all have to be on the same plane. It can't be a three-dimensional figure. And so what we're going to look at then is when we look at quadrilaterals and the different types, what are the measures of the angles? What are the sides that are parallel or opposite sides that are parallel? And also the diagonals. And if we look at this picture here, a diagonal would be from corner to corner. So there's a diagonal from D to B, and there's a diagonal from C to A, and you'll see that in your definitions. There are different types of quadrilaterals, and we can see that this DCAB quadrilateral is not a square, it's not a rectangle. Anytime you have a quadrilateral that has two sides that are parallel, and in this case the two sides that are parallel are AB and DC, it is called a trapezoid. And you'll explore some of these as the unit goes on. If we drop down C to E on the second diagram here, and we look at the shape that is now created where all four corners are 90-degree corners and opposite sides are not only parallel but equal, well, that would be a rectangle. And so we now have a different shaped quadrilateral. So when we look at the properties, it all goes back to these. When we talk about the angles, what are the measurements of the angles? And so you're going to use a protractor. Which sides are parallel, and you can usually tell just by looking, and how long are the diagonals. And you're going to compare again from corner to corner. Are the diagonals the same? And I think on this one, if I believe, and you'll probably verify it later, these two diagonals that I just drew would be the same, whereas if I draw the diagonals on this other trapezoid that is not an isosceles trapezoid, those would not be the same. You're also going to have to deal with some problems involving area and volume, and if we look at the picture here, you're going to be asked at some point to measure. An important thing for us to know here is whenever you're trying to find the volume of any figure, which means the amount of space it takes up, it's basically the area of the top multiplied by the height. So when we look at this figure here, which is a trapezoid, we'd have to know how to find the area of a trapezoid. And when you get to your assignment, if you don't know, just come ask me and I'll help you. And then you would times it by the height, which in this case would be the distance all the way from there to there, and that would get you your volume. And in this problem, you would have to figure out how many meters cubed it is, and then divide that by 1,000, because there's 1,000 liters in 1 meter cubed, which makes sense if you think of a meter by a meter by a meter. That's a pretty big section of water. The other types of quadrilaterals that you're going to see are a rhombus. A rhombus is a quadrilateral that has all four sides the same, but they don't meet at 90-degree corners, so it's like a parallelogram with all four sides the same, whereas a parallelogram is a side with opposite sides equal and opposite sides parallel. You'll also need to look at a kite, and a kite is a parallelogram that has a unique feature in that these two sides are going to be equal, and then these two sides, SR and QR, would also have the same measure. And you can see the diagonals for the kite meet at 90 degrees, the diagonals for the rhombus meet at 90 degrees, but the diagonals for the parallelogram do not meet at 90 degrees. So one of the activities you're going to do is, starting on page 196, there's a game that you're going to play, and in order for you to play the game, you're first going to have to make a table that helps you to check off checklists, or characteristics, pardon me, for each of the quadrilaterals. And then you're going to make these quad cards, and you'll play the game with your classmates. Now that is assuming that there are classmates at the same place as you. If not, you may have to go on to the assignment, which is on page 198, master the assignment, and then maybe go back and play the game as a way to review. Don't forget to fill in your definitions on your definitions page for chapter 5, and don't forget to get your check done as well as your math on the job and roots of math. Otherwise, that's it for this lesson, and I will help you when you need help.